Okay, let's unpack this. Imagine you ask an AI for a joke, right?
Yeah.
It delivers, you chuckle. For a moment, it feels like success. Done deal.
Right. Job done.
But then maybe this little voice whispers, where did that joke really come from? You know?
Ah, okay. I see where this is going.
That seemingly simple question, well, it cracked open a whole new world of understanding about how these AI agents truly operate.
Hmm.
So today, we're diving deep into what happens when your AI agent is basically a black box. You see the inputs, you see the outputs, sure.
But the middle part.
Exactly. The actual processing, the decision-making, how it used the tools, it's all hidden from view.
Yeah. Opaque.
Our mission today, explore this whole phenomenon, figure out why it matters so much, and, how we can maybe get some critical transparency.
And what's fascinating here, I think, is how just a simple everyday interaction like getting a joke can shine a light on such a profound and really pressing issue in tech right now.
Yeah.
It's not just about a joke, is it? It's really about trust, verification, understanding the true actions of our AI systems.
Yeah.
Especially, as these agents get woven into more critical parts of our lives. Think customer service, healthcare.
That's a really critical insight, the real-world impact. It hits home. And it's fascinating how this whole thing started. Like, the realization wasn't some big academic debate.
Yep.
No, it was actually a developer feeling pretty good about their latest AI agent setup. Simple stuff.
Yeah.
They had this model context protocol server, MCP server, running, hooked it up to jokepie.com, ready to fetch jokes.
Sounds straightforward.
Looked perfect. Agent configured, tools registered, so the developer types, hey, agent, tell me a joke. Simple request.
And did it work?
Oh, yeah, it delivered. Why don't scientists trust atoms? Because they make up everything.
Okay, classic.
Gotta chuckle, right?
For a second, it really felt like, yes, mission accomplished. But
Yeah.
that little voice started whispering again. Just where did that joke come from?
The nagging doubt. Exactly. That's when the developer realized, okay, they wrote the code, the setup code, but they had no idea how it truly worked internally, like zero visibility. The agent could claim it called the API, sure, but proving it actually made that specific HTTP request surprisingly difficult, almost impossible, really.
Wow.
And that led to the conclusion that this fancy AI agent was essentially a black box wrapped in promises.
Promises you can't easily verify. That's the key.
Right, and it makes you wonder, doesn't it? If you can't even trace a simple joke reliably, what else is happening under the hood?
Well, this is such a classic dilemma. It really echoes a fundamental concept we've dealt with for years in traditional software development. Black box versus white box testing.
Okay, break that down for us.
Sure. So black box testing, you're basically focusing only on the inputs and the outputs. You put X in, you expect Y out.
Don't care how it happens inside.
Exactly. You don't peek inside the box. It's great for checking the user experience, catching really obvious bugs, that sort of thing.
Makes sense.
White box testing, though, that's completely different. You're deliberately looking inside, examining the internal structure, the actual code paths, the decision logic.
You see everything.
Pretty much. You see exactly which functions get called, which branches are taken, how variables change. And this kind of visibility, it's absolutely crucial for finding edge cases, verifying security, understanding performance, the tricky stuff.
Okay.
And the core problem for AI agents right now, we're essentially stuck in like permanent black box mode.
Permanent black box mode. That sounds bad.
It kind of is.
Mm-hmm.
Because even when we write the orchestration code, the high-level instructions of the AI's actual decision-making process, the reasoning, it stays opaque, hidden.
So you can't just step through it like normal code.
Nope. You can't step through its reasoning. You can't see which tools it actually uses versus which ones it maybe just claims it used.
Or thinks it
Or thinks it used.
Right.
And you certainly can't verify its internal logic easily. So that AI black box, it could be getting fresh jokes like it's supposed to. Or maybe it's just recycling old ones from its training data. Or maybe it's making up entirely new material. And we'd have almost no way to peek inside and verify what actually happened.
So this black box problem, I mean, it sounds a bit abstract when we're talking about jokes, right? But how does this translate into like real world scenarios, the kind that might actually keep developers up at night?
Oh, absolutely.
What are some of those scary possibilities? The source mentioned a few.
Yeah, the source material paints some really vivid pictures. And frankly, they're quite unsettling when you think about them. Like, imagine an agent, let's call it the overachiever.
Okay.
It calls 5 different APIs when just one would have been perfectly fine. Wastes resources, slows everything down, costs more money.
About unnecessary complexity.
Totally. Or think about the lazy agent. It just fakes it, uses old cached data, but presents it as fresh.
Ooh, that's bad. You'd be acting on stale info.
Exactly. Then there's the confused agent. It hits a snag, maybe an error, gives up silently, but still logs the operation as a success.
So you think everything's fine, but it actually failed.
Precisely. Leading you down the wrong path.
Right.
And maybe the weirdest one is the identity crisis agent. It genuinely thinks it made an external call, like to an API, but it didn't. It just hallucinated the interaction.
Wow. Okay, so this isn't just academic. It's about the real gravity of the situation as these agents handle more and more critical tasks.
Definitely. This observability gap, as the source calls it, it becomes deeply problematic across so many important AI applications. Just think about it.
Like what? Give me some examples.
Okay, customer service. Did the agent actually check your latest account status? Or is it just giving you a plausible-sounding generic response based on its training?
You wouldn't know.
You wouldn't. Or financial apps. The agent says it's pulling real-time market data. Is it really? Or are you about to make a critical investment decision based on information that's maybe 5 minutes or an hour old?
Yeah, that's high stakes.
Hugely high stakes. And healthcare. If an AI assistant claims it reviewed the latest medical research for, say, a diagnostic suggestion, you absolutely need to be sure it actually accessed that current research.
Life and death, potentially.
Could be. Even in software development itself. Your AI coding assistant says it's using best practices from the brand new framework documentation. Did it actually access that new doc, or is it just winging it based on older stuff it was trained on?
Yeah, it makes you question everything.
It really reinforces the critical takeaway here. AI agents are starting to touch everything. Customer service, finance, healthcare, coding.
Yeah.
We absolutely must know what they actually do, not just what they say they do. Without proper logs, without proof. Agents that chain actions across multiple tools and APIs. Well, the source describes it perfectly.
Yeah.
It could become a game of telephone with hallucinations.
A game of telephone with hallucinations. That's a vivid image. And it really boils down to trust, doesn't it?
Fundamentally, yes. It's a huge trust issue.
Okay, so the problem feels enormous. Kind of scary, actually. Is there any light at the end of this black box tunnel? Are developers working on solutions? How do we get that transparency we need?
Well, yeah, here's where it gets really interesting, actually. Because there is a promising solution emerging to tackle these observability challenges head on. It's called the Model Context Protocol, or MCP.
MCP. Okay. Tell me about it.
So MCP, it's basically an open standard. It's designed specifically for secure two-way communication between the AI language models and all those external things they need to talk to, databases, APIs, file systems, other tools.
Like a universal translator.
That's a great way to think about it. Yeah, like a universal translator, but with security built in. It lets the AI agents safely interact with these resources without, exposing sensitive data or compromising the system.
How does it standardize things?
It standardizes how the AI systems request access, how they authenticate themselves, and basically how the data flows back and forth between the AI and these external systems. It puts guardrails around the whole interaction.
Okay, interesting. And the source mentions some specific components of MCP that make this work.
Exactly. There are a few key pieces. First, you've got the MCP server. Think of this as a standalone program that basically exposes specific capabilities, tools, data resources, maybe predefined prompts to the AI clients. It acts like a secure gateway.
Got it. Gateway.
Then there's the MCP client. This is the AI application or the agent itself. Maybe something like Claude Desktop or a ChatGPT Plus plugin that connects to these MCP servers. It uses them to discover what tools are available, make requests, and then handle the responses that come back.
Okay. Server and client. What else?
Well, then you have the tools themselves. These are the specific functions or capabilities that the server offers up. Things like search database, send mail, fetch weather data, you name it. Importantly, they're designed to be stateless and have clearly defined schemas so the AI knows exactly how to use them.
Makes sense. Defined functions.
Right. Then resources. These represent data or content the AI might need access to, log files, documentation, maybe previous API responses. They're identified by URIs, like web addresses.
Data access.
And prompts. These are like reusable templates or instructions that the server can provide. They help guide the AI agent on how to use a specific tool effectively or how to format its response properly. Kind of like little cheat sheets.
Handy. And how does the communication actually happen?
That's the transport layer. It handles the back and forth communication.
Yeah.
MCP is flexible here, supporting different connection types. like standard input-output, server-sent events, SSE, and WebSockets.
Wow. Okay. It sounds pretty comprehensive. A lot of thought went into structuring that interaction.
Absolutely. And the key thing is how all this directly addresses that black box problem we talked about.
Hmm.
MCP helps transform these AI systems into more like gray boxes. Not totally transparent maybe, but much less opaque.
Gray boxes, I like that. How does it achieve that? What are the mechanisms?
Well, several key things. First, it provides structured logging. MCP has standardized logging formats, often with different severity levels, making it way easier to track exactly what your AI agent is actually doing, step by step, not just what it claims it did.
Okay, better logs. That's crucial.
Huge. Then there's request tracing. Every time the agent calls a tool through MCP, it's captured, often as a structured message like JSON RPC. This creates a complete audit trail of all the agent's interactions with the outside world.
Audit trail. Essential for debugging and accountability.
Definitely. And it even includes things like debug tools. The source mentions a built-in MCP inspector and real-time monitoring capabilities. These let developers literally see exactly what's happening under the hood as the agent operates.
It's like looking inside the gray box.
Precisely. And what's really crucial here are those explicit tool calls and the complete audit trail they create. With MCP, you can see exactly when an external API was invoked. You can track the HTTP request, the response, even the timing. No more guesswork.
That sounds like the proof we were missing with the joke example.
Exactly.
Yeah.
The source even gives a little snippet of what an MCP log output might look like. It's just an example, but you can see how clear it is.
Yeah. What does it show?
It shows a JSON message with a method tool call. It clearly states the name of the tool being called, in this case, fetch joke, and the arguments used, like source, joepp.com.
Ah.
It's literally JSON.RPC 2.0 method, tools call, params name, fetch joke, arguments, source, joepp.com,
Yeah.
param 13. That right there, that's the proof. That's the verifiable trail we desperately need to build trust in these systems.
That is clear. That's actual evidence of the action. And you mentioned this isn't just theoretical, right? People are actually using this.
Yeah, absolutely. It's
Yeah.
gaining traction. We're seeing growing industry adoption. Major observability platforms, think New Relic, Dynatrace, Mosif, are starting to offer specialized monitoring specifically for MCP.
So the tooling ecosystem is building up around it.
Exactly. And there's active development happening to integrate it with things like OpenTelemetry for even broader tracing capabilities. It really feels like a tangible step forward for the whole field.
Okay, that's genuinely encouraging. So with MCP and this move towards gray boxes, what are the practical takeaways? What are the best practices that developers and maybe even users should keep in mind?
Well, the source lays out some really clear, actionable advice.
Yeah, I saw those. Like, trust, but verify. Don't just take the AI's word for it, demand proof, or at least look for the evidence in the logs.
Precisely. Which leads to the next one. Embrace logs. Make detailed logging a priority. Log the agent's intent, what it attempts, and importantly, any failures.
Right. Don't just log success.
Definitely not. And then test boundaries.
Yeah.
This is interesting. Try disabling tools the agent relies on. Does it notice? Does it adapt? Or does it just pretend everything is normal? It tells you a lot about its actual awareness.
That's a clever test. Kind of like pulling the rug out.
Sort of. And maybe the most fundamental point,
Mm.
build for observability. Don't treat transparency and monitoring as an afterthought you bolt on later. Make it a core part of the system design from day one. Foundational.
Make it foundational. That seems key.
Yeah. And look, while MCP doesn't magically solve the entire AI transparency problem, like understanding the model's internal reasoning is still hard. It makes a massive difference. It really does transform these systems from completely opaque black boxes into these much more manageable gray boxes.
Giving developers the visibility they need.
Exactly. The visibility needed to debug effectively, to monitor performance, and ultimately to actually trust that their AI agents are doing what they're supposed to be doing.
And why should, someone listening who isn't a developer care about all this?
Because ultimately this matters to you. It's about building justified trust in the AI systems we're all starting to interact with every single day. And it's about being able to demand accountability for what they actually do, not just what they output.
Right. So, back to the beginning.
Oh.
That joke, still funny.
They're funny.
But if my agent wasn't telling jokes, if it was, making critical business decisions or managing my finances, I definitely want proof. Not just a plausible sounding chuckle.
Absolutely. And this really raises a super important question for all of us as we build and use these systems. We need to start asking harder questions.
Meaning
Meaning not just, can the AI do this task? We know they can do amazing things. The real question needs to become, did it actually do it? And can you prove it did it?
Did it actually do it? That's the core of it.
It really is.
Because in the end, observability, this ability to see inside, it isn't optional, is it? It's absolutely essential.
Couldn't agree more.
Essential.
So as you interact with AI, maybe it's customer service, maybe your smart assistant, maybe some new app you're trying.
Just take a moment, consider that black box. What questions would you start asking to get a better sense that what the AI says it did is what it actually did? Just something to think about. The real implications of transparency in these powerful systems shaping our world.